Okay, so we're now going to be looking at the case of risk aversion, a decision maker who does not like risk. So we start with a simple example that we had in the case of risk neutrality. We can consider different states of the world. Okay, so there's risk. Something has to be able to happen. We don't know what the future will bring. And for simplicity here, we think of three states. So we can call them low, normal, and high. So this could be, the level of rainfall, if we're thinking of a farmer, could be the level of the stock market, if we're thinking of a stock investment, could be, pretty much anything, where these are states of the world that describe, the relevant setting for the decision maker. She has different actions, call them A and B, could be planting a certain crop. This would be planting another crop, could be investing in this type of stock, could be investing in another type of stock, could be investing in a particular type of factory and another type of factory. It could be lots of different things depending on the setting that we're thinking of. And then we have the outcomes. Your harvest is going to be depending on your actions. What did you sow and how much rainfall did you have? And the case that we looked at before had 2, 4, and 6 as outcomes. So higher states, more attractive states are associated with higher outcomes. But we also had that the outcomes were depending on the actions that you took. So in particular here, we could see that under normal times, both actions give the same outcome. But in low states, action A does better, whereas in high states, action B does better. Okay. So a risk-neutral decision maker, as we saw before, would be indifferent between these two actions, at least in the case where we have probabilities. Let's assign the probabilities here. Say that probability is 1/3 for the low state, 1/3 for the normal state, and 1/3 for the high state. Okay, then these two actions have the same expected outcome. So a risk-neutral decision maker would, under these conditions, be indifferent between the two. But risk aversion says that we don't like risk. So if there was no risk, if we were certain that we would be ending up at the normal situation, 4 here, well, clearly 4 is equal to 4, so that decision maker would still be indifferent between them. But now assume that, there is indeed probability out in the tails here. There's a probability in the third that we have the low outcome, a probability in the third that we have the high outcome, and this will potentially affect your choice. So say that this is a farmer, outcome of 0, no crops at all in the year, not too attractive. Okay, and so if I choose action B, yes, if it's a bumper year, I'll do better, but I'll be starting here, and I'm willing to put some weight on that. So indeed, risk-averse a risk-averse decision maker will assign different utilities to the different outcomes. And in particular, will be putting a lesser weight on higher outcomes and a larger weight on lower outcomes. So we can think of different utility functions, formerly von Neumann and Morgenstern utility functions, whereby she assigns those weights to the different outcomes. One example of the kind of utility function that we could look at that would be associated with the risk-averse decision maker. We'll talk more about that class of utility functions in a little while. But one would be where utility is given by the square root of the outcome. So y here would be 2, 4, 6, for instance. So this is saying what? Well, we're saying if we're looking at utility of action A, we have what's expected utility? Well, it's a probability of the low state, so 1/3, times, now we're not looking at the outcome, but we're letting this be weighted, so the square root of 2 plus the probability of the normal outcome, 1/3, times the square root of that outcome, 4, plus the high outcome, 1/3, probability of that high outcome, times the square root of the outcome under that state. And this is approximately equal to 1.95. Okay, so if we're looking at utility of action B, the expected utility of action B, similarly, the probability of the low outcome times utility of that outcome, square root of 0. Similarly for the normal outcome, 1/3 times square root of 4 plus 1/3 times square root of 8. And this is equal to 1.61. Okay, so we can also illustrate this in a graph. Thinking of the case where this is rather than just 3 points, we could, for simplicity, think of a continuous set of states when we're drawing the graph. So we have states, low, normal. This is looking ugly. So let's redo here. Low and high here. And we have utility on the vertical axis. So if we're looking at action A, utility is, we have here, intercept square root of 2, and then square root. So we have an increasing and strictly concave function here. So this is utility of action A. Okay, so this is, as we said, strictly, it's increasing, but strictly concave. So it increases, but at a decreasing rate. So we can say this is similar as if we have decreasing marginal utility of income. You value additional income a lot at low levels. You value additional income less when you have a lot of money. Okay, so it's a similar here, and we're evaluating then these outcomes using this strictly concave utility function. Okay, so an example of such a utility function would be the square root of y. We could also have what we sometimes call log utility. So the natural log of outcome would be another type of utility function. So one aspect of a risk-averse utility maker, or risk-averse of the choice of different actions for risk-averse utility maker, is of course that she does not like risk. She can be compensated for it. So if this were not 8 but 20, that would be enough to entice her to choose action A. But let's look at a concrete example of that. So here, let's do a mean preserving spread of the states here. Say that the probability of the normal is equal to 0, and we're redistributing that probability mass to the tails. So the probability that you get low outcome is equal to 1/2. The probability that you have a high outcome is equal to 1/2. So you're going to be in one of the extremes. It's a mean preserving spread. So on expectation, it's like normal times, but it would actually not be that. Will be either in the high or the low state. So what's the utility for this decision maker then? Well, it's probability of the low state times, we're looking at action A, so the square root of 2 plus 1/2 times the square root of 6. And that's about equal to 1.93. So less than in this case. So this mean preserving spread, the increase in risk, was associated with lower utility. Action A has just become less attractive to her. So has action B, by the way. We can also illustrate this in the graph here. So we're thinking we'll be either in the high or in the low state. So the expected utility will be, you can think of that as somewhere on a straight line from connecting these two points. So this individual will be either here, getting that utility, or here, getting this utility, and weighing those with one probability of 1/2 of each will be associated with an expected utility of 1.93. Okay, if she instead were certain that she would be having that the state would be the normal one, the normal state would be realized, we would be having this utility, which is so the square root of 4 equal to 2. Okay, so risk aversion associated with a strictly concave utility function, or in other words, we're putting less weight on high realizations. And we see here sort of mechanically what does strictly concave utility function imply? Well, it implies that, you know, if we're tying a string between 2 points on that function, it's always going to be below the function. Okay, so this is how we can operationalize the case where a decision maker is risk averse.